So good afternoon, everyone. No? So last meeting, I gave you an assignment to do an application regarding branching. But we did looping before. Branching is an important aspect or an important feature in a programming language. It allows your program to make decisions. No? Like the example I've shown you, it's an example to create to decide whether raw score is passing or not. Do you follow? So what language are you using in your other class? Again, may I ask? Diba you're using a language? C++ ba? Oh, okay. Let's do it both. No, let me review you C++, Python muna, no? Python program that determines whether a raw score, no, is passing or not. Okay. Programs, where's that? Okay. Python, no? Grade computation.py. So here's a Python interpreter. Okay, if you those who don't know Python, no, input is the command to ask input from the keyboard, right? So I am asking here three variables: S as the score, I as the items, and B as the base of computation. Okay. In Python, when you use input, the return is a string. Typeless, no? Python is typeless, so you don't declare variable types. Okay, so if you run this like that, no? Anyway, it just asks, let's clear this. Let's complete. Let me complete this first, no? So this a simple program that computes the grade. You run, for example, if you have 60 or 50, no, 100, the base of conversion is 4. The grade is 70, no? You know how to compute the grade, no? I've introduced this to you last meeting. The base being the lowest possible grade. Now, let us introduce an if then else statement. This is how you do a branching in Python. You have an if followed by a condition, terminated by a colon. And then the body which you want executed should be indented inside the if. Okay, any questions? And the else branch is executed if the condition is not satisfied. Okay, so if we clear and then run this, okay, we have 60, 140. Okay, so it declares 76 as a passing grade. On the other hand, if you have 40, we clear this, I made a mistake. 40, then 100, I'm sorry, clear it. 40, 100, and the base is 40. So your grade is 64, it's not passing, okay? So that's branching. Now, if you are doing a C++, here's the equivalent. Okay. So you can either use IOStream or stdio.h, the classic stdio. No? Okay. For those of you who are not using C++, you declare all the variables first. Okay. Because C++ is a type language. So we declare S and I and B as float. These are floating point numbers. No? G as grade is also float. And then we print the string, enter a raw score. Cin is the input. We'll put it in the variable S. Cout asks for items again and stores it to the variable I using cin, and so on and so forth. No? So here's the if then else. No, is greater than or equal to 75, or maybe in our case, we can say 74.99. Okay. So here is the branching part. Is there something wrong? It turns 0, no? So may error tayo dito.
Kulang ata nung curly bracket sa answer.
Oo, nawala ba? Oh, yes. No. Thank you. No? Curly brace. Okay. So you have 60, 100, you have 40, 76. Now, if you run again, you have 40. That's a pass. That's a failing grade for about 40 base. No? So, okay, that's a failing grade. Now, in our example, last time, we had this, no? The grade computation, no? Here is how it's done, no? In the analytical engine. Lang. So here is the part where the raw score is converted into a grade, which is 76. And before we do the if then else, we assume it's a failing grade. Okay, so L006, which is 0, multiplied to L005, 0 times 1 is a 0. We assume it's a failing grade, and we check if it's it's greater than 74.99. We do that by deducting L008. Ito, nandito sa 008. 008 is our cutoff grade, no? Here, no? Okay. 008 with the raw score. If it's negative, we see now maybe you will use CF3. It's okay, no? Kasi 1, 2, 3, no? If you start here, but my convention, which is okay, all right for the moment, no? So in this case, for example, since it's passing, it will skip up to this point, and will correct the judgment from 0 to 1. Okay, do you follow? Now, considering, for example, the last grade that was taken is 74, okay, this will be a 0.09, and the run-up lever will be 0. Do you follow? For 76, by the way, this is a negative. This is a 1. Okay, do you follow? That's why it's skipped. So the CF command in the analytical engine is used to do branching. It's like an if-then statement. Of course, you have to couple it with a minus. Okay? Do you follow? The minus combined with the CF is actually the analytical engine's version of branching, if then else. So, in conclusion, no, the analytical engine, as crude as it was, remember, it was invented in 1637, can already do a lot of things that a modern computer can. Okay? Diba? It does computations. It does access to memory, load and store, and it can do looping using CV, and it can also do branching using CF. Okay? So according to Alan Turing, no, the analytical engine is a complete machine by itself. No? Okay, by itself, it's already a complete machine. Okay. Any questions so far? Which brings us to a new lesson. Okay. Who was the last one who came in? Limana, Tristan.
Apo, sir.
There was someone else.
Ako po ata, sir.
Your name, please. Hindi ko
Luis Paul Rojas po.
Luis Paul Rojas. And we have lately? Sino pa isa? Who just came in?
Alinsan, sir.
Allen San. Okay. Okay. Any questions? So let's. So after the war, no, there was a competition among universities in the US to commercially or to produce the first binary computer. Actually, ENIAC, which was released in 1945 or 1946, somewhere after the war. It started during the war. Filed for a patent. Eckert and Moakley filed for a patent for ENIAC, but the patent was later withdrawn because there were controversies regarding the design of ENIAC, whether it was original or not. Okay, so during that time, there was a competition to first release a binary computer. In competition was Princeton University and Penn State University. In Princeton University, there was an Institute of Advanced Sciences, and there was a professor there named John von Neumann. He later transferred to the Institute of Advanced Sciences to design the first computer, binary computer. It was called the Stored Program Computer, or the IAS computer. Before that, Eckert and Moakley organized a team also to compete or to produce the first binary computer. They called the computer EDVAC. EDVAC and the IAS were both released in 1951. But who is considered the first? Later, there was a controversy with EDVAC also, like ENIAC. So that the stored program concept was accredited to John von Neumann. Okay, John von Neumann is a very important figure in computing history. Okay, why? Because he invented a very important concept, almost as popular as Charles Babbage and Ada Augusta King. Okay, you follow? So, and Alan Turing, of course. Let's look at that. Remember that Alan Turing finished his PhD in math in Princeton University. Okay, which brings us to the stored program concept. Ano, mali pala yung pinuntahan ko, no? Ano, sorry. Okay. What is the stored program concept? Anyone? It was introduced in 1945, and the IAS machine was completed in 1951, okay, by John von Neumann. Sometimes the John is spelled without the H. No? Here's how it looks. Okay, ito, no? Here's the author, no? This is John von Neumann. Okay, there he is again. Okay. Okay. Now, it is called Princeton class computer because during those times there are two classes, no? Harvard class, which is the same as the analytical engine, and Princeton class, which is the stored program concept. Okay. So Harvard architecture is like the analytical engine, and Princeton architecture is like the IAS. Okay. The IAS machine, like the analytical engine, uses a 40-bit word, but this time this is binary or base 2. Okay. The strange thing about this is with the memory being used both for instruction and data. Okay. Instructions come in 20 bits and data come in 40 bits, which means that two instructions can fit in one memory unit. No, negative numbers were represented using 2's complement format. Okay, so all in all, no, 1024 words. The analytic engine is supposed to have 1000 words. Ang IAS is 1024 words with 40-bit words each. No, the byte was not yet popular during the time. No, so 40-bit words times 1024, that gives you about 5.1 kilobytes. Any questions? No? Let's make a comparison between the analytical engine and the IAS. In terms of the binary number system, they're both 40 digits, but the analytical engine is fixed point. Okay, the IAS is floating point and binary, which means base 2. Floating point representation is more accurate than fixed point, no? Because it can accommodate small numbers and big numbers. No? Now, in Babbage design, the computer only has one mill. Okay, with 2 input registers and 1 output register. Okay. Now for John von Neumann, the mill is now divided into 2. Okay, we split the function into 2. Okay, he called it the ALU, or the arithmetic logic unit, and the program control unit. Okay, the arithmetic logic unit does the arithmetic, and the control unit does the execution, the fetch and execute, because programs are a series of instructions that are fetched one by one and executed one by one. Okay. In the analytical engine, the mill functions both as the arithmetic controller computer and the fetch and execute of instructions. Okay, so in the IAS, it's split into 2. Okay, we look at the registers later. For the input and output, no, we know that the analytical engine uses a Jacquard loom. Okay, so doon galing yung mga instructions. For the IAS, program and data is read into main memory first, which means it may come from an input device like a tape drive, and they can be stored back to an output device like a punch card. Okay, so what is the stored program concept all about? How is it different from the Harvard architecture? Anyone? Kasi in the original idea of Charles Babbage, the program comes from the input device, like a hard disk. You follow? Only then, these were a series of punch cards. Okay, do you follow? Now, these programs are fetched instruction per instruction sequentially from one card to the next. Diba? It is fetched, executed, fetched, executed. Data is stored in the punch card, or rather, the instruction is in the punch card, and data are stored in the store. Diba? Variables are in the store. So there's separate storage between data and instruction. Okay? Do you follow? So ang data nasa store, ang instruction nasa Jacquard loom. Now, John von Neumann didn't like this because he sees a very important defect. Can anyone tell me what's wrong with the Harvard architecture? Anyone? Okay. There's a big difference between the speed of the store and the speed of the input device. Or nowadays we call it the speed between memory, and the hard disk. Di ba? A hard disk or even an SSD is much lower than memory. Do you follow? Do you get my point? Okay. Such that if you are going to execute programs instruction for instruction from the hard disk, it will be very slow, right? Kasi the hard disk is very slow. Even if you buy a very hard hard disk, a very fast hard disk, it will not change the speed. Did you get my point? So, what's the suggestion of John von Neumann? Anyone? Instead of processing data one by one from the hard disk, let us store the program first as a whole, in whole, no? By one batch, no? By a batch, from the storage device to the memory. Okay? Do you follow? Store that in. Once it's transferred to the memory, okay, it is then processed command per command. So in this case now, instructions and data are both stored in memory. Unlike in the Harvard architecture where data is in the memory and program is in the loom or in the input device. Do you get my point? Okay. So instructions are then fed sequentially from memory to CPU during program execution. So program execution now comes into two cycles, fetch and execute. Do you follow? You get my point? So until now, no, the stored program concept is in use. If you have an exe file from a hard disk, what's done by your operating system is to load the exe file from your hard disk to memory before it's run. Do you follow? Hindi pwedeng i-run from the hard disk. Now, will there come a time that will be obsolete? Who knows, no? Because there are hard disks now that are becoming very fast. Intel, no, is developing an SSD which can run as much as 25% of the speed of memory. So 1/4 na lang. Currently, no, memory is magnitudes faster, 10,000 times faster than hard disks. But if the hard disk will be as fast as memory, then there's no need for the stored program concept. Okay, whether it happens or not, who knows, no? Depending on the movement of technology. Okay. Any questions? So you I hope you understand, no, the stored program concept, no? Because that's what we will be doing or using from then on. Okay. Here is the IAS computer diagram, no? This is like the mill. Now it has a data processing unit or the ALU and a program control unit. Okay. We only have one accumulator register, which is the accumulator. This is patterned from the ENIAC, which has 20 accumulators. Okay. Now, in here we only have one accumulator. No? The arithmetic logic unit does the arithmetic. We'll discard these registers for the moment. No? The control unit has three registers. No? IBR or the instruction buffer register, the program counter, and the MAR. The instruction buffer register contains the instruction from memory, which is fetched. Before it's executed, it is split into two parts. The instruction is in the IR or instruction register, and the operand goes to the MAR or the memory address register before it's executed by the control unit. The program counter points to the address in memory of the instruction being fetched and executed. Okay, it processes it one by one. Okay. Any questions so far? During those times, no? Before you can program a computer, you have to understand its architecture. Okay. Now, here is the instruction set. Can you see this? Is it clear? No. Now, the instructions are borrowed. A lot of the instructions are borrowed from the analytical engine. You see, we have load and store. No? Store MX transfers the content of the accumulator to location X in memory. Do you follow? Do you follow? Load MX transfers the location, okay, of memory X to the AC. Okay, it's like L001. Okay. However, the difference is it goes only to one register, which is AC. No, the sequence doesn't matter. It always goes to the AC register. And AC will always be the source of any store. Okay? Do you follow? Although in the analytical engine, it's the egress register. Any questions so far? I hope it. So it's clear now. And then there's add, sub, mul, div. No? In the analytical engine, we have plus, minus, times, divide. Okay. We had also a left shift and a right shift. Okay. Now, there are jump instructions that can alter the sequence of the execution of the program. No, but since instructions can fit in two instructions can fit into one memory word, you have two jump instructions. A jump will transfer control. No, jump left means jump MX 0 to 19, which means jump to X on the left part. Okay, or jump MX 20 to 39, which means jump to X the right half. Okay, the right part. Okay. Any questions? Now we have a special jump plus. This means that we jump only if the accumulator is positive, 0 or positive. Non-negative, okay? Do you follow? So you may ask, oh, this may be the equivalent of CB, right? Which means that we can use this in converting our analytical engine programs to the IAS. Are we correct? Anyone? Any idea? Can we use jump plus as a substitute of CB when we translate our program? Any volunteer? Jason, Ungala, are you there?
Yes, sir.
Can we use that? Can we use that as a substitute? Yes, you say yes. There's a problem because they are not the same. Why? Because CB will jump if the egress register is negative, right? And jump plus will jump if the accumulator is positive. So hindi pwede. Do you follow? So later we are going to have an assignment which translates the IAS programs into, rather the analytical engine programs to IAS. You have to be careful because the commands are not the same. Like jump plus is not exactly CB, but however we can still make, no, programming is an art, no, we can still make do with it. We can still use branching and looping using jump plus. Okay. Any questions? We'll discuss that, no, in our near future, no, in one of the classes later, no, maybe next week. Okay. So let's take a look at the sample program. Okay. So you can download this program Here, oh, sample IAS programs. Okay. Anyway, it's in my downloads. So I can just, open it. Here is the IAS program to compute the fourth factorial. Can you see my worksheet, everyone?
Yes, sir. Yes, sir.
Okay. The fourth factorial now. The only difference is we have the memory here as M0, M1, M2, M3, M4. No? We have the instruction here, and the instruction and data are in the same memory. They come in different addresses. Usually, no, in a program, data is stored first, followed by the code. Do you follow? So usually, the area which contains data is called the data segment, and the area which stores the instruction is called the code segment. Okay. Now the first command in a program should jump to the first instruction in the code segment. Like in this case, jump 50 to 19. Any questions about this? Which means right away, the processor will go to 5L. Okay. Remember, there's 5L and 5R because R is supposed to be at this point. But, okay, we cannot write a program horizontally and vertically at the same time. Mahirap i-trace. So what we'll do is just restore them sequentially. So now, data and program are on the same location, are on the same medium, which is the memory itself. Any questions so far? So we have the command address, the location, now in memory. Remember, instructions are designated 6L, 6R, 7L, 7R, but data is just 1, 2, 3, 4. Okay? And then you have to be used to this. These are micro instructions. No? This designate the flow of data. When we say load M1, the micro instruction is actually AC receives M1. Do you follow? And when we say store M4, M4 receives AC. Do you follow? And we say sub M2, we mean AC receives M of 2, AC minus M of 2. Store M1, M of 1 receives AC. Do you follow? So the load and store are very similar to the analytical engine, only a different syntax. Okay. So this is our memory. This is the same memory, no? We are having on the left, on the right. Okay. Okay. So M1 here becomes 4. M0 contains the first jump. Okay. M2 becomes 1, and M3 becomes 1. Okay. And our partial product will be in M4. So there's a little change, no? Anyway, you can use any variable you like. So shall we trace this? Okay. IAS na ito, no? Iba na. No? Dapat makita pala, no? Load M1. What's the value of the variable AC? Or rather the register AC? Anyone? Shall we ask? Carl Luis Campos. Wala. Jesse Manuel Telmo.
Sir. Okay, mali, sir.
Ha? Come in.
Okay lang kung mali.
Sige lang.
Under 4, sir.
4. That's correct, right? Because M1 here is 4 and AC receives M1. That's correct. Anyway, no? Everybody makes mistakes. Even I, no? I make a lot of mistakes. If I make a mistake, you correct me, no? Okay. Programmers make a lot of mistakes. Okay, because sometimes you turn sleepy, turn tired, You press a wrong key and yeah, it makes the mistake. Okay. Now we say store of M4. Store M4. Okay. Joshua, Samuel Suarez. What will happen to M of 4?
Wala po akong idea, sir.
No idea? When you
No
say
idea po.
store M4 means M of 4 receives AC. This is M of 4, right? Joshua, ito yung M of 4, right? Do you see that?
Yes, sir.
So what happens? What value will be stored there? The value from AC. Diba? Diba, Joshua?
Yes, sir.
What value?
4.
4. Okay? Ganun lang naman eh. Paunti-unti, no? Little by little. Sub M of 2. Sub M of 2 means we subtract 2 from AC and store it to M of 2. Do you follow? So what becomes of AC? Dennis Divo?
Yes, sir.
Come again?
Hello, sir. Can I do it, sir?
So, sub, what is M of 2? M of 2 is 1.
Sir, kay 1.
Oh, sige. So what is sub M2?
1, sir.
No, it becomes 3.
I see.
No.
Okay.
Diba? Because it's 4 minus 1. It's 3.
4 minus 1.
So that's how you trace it. It's similar to the analytical engine. Kaya lang mas shortcut. Kasi sa analytical engine, you do a sub first before you do a store. Diba? Do you follow? Dito, you can do the sub and the store at the same time. Do you follow? Okay. Store M of 1. So 3 here becomes, M of 1 here becomes 3. Any questions? No? And we say mul M4. Mul M4 means we multiply the AC 3 with M of 4, which is 4. So what is this? Luis Paul Rojas,
Yes, sir.
what's the value of AC here? At mul?
AC. Still 4, sir?
No, it's currently 3, right?
Oh, yes, sir.
And then you multiply it with M4. What is M4?
Ay, ito. Okay. AC times M4. 4 times 12. Wait, 4,
Yes,
8, 12.
that's correct. 12. Why? Because it's 3 times 4. Now, it's a shortcut, right? Kasi kung sa, ano pa ito, you load M4 before you do a mole. Di ba? In the analytical engine. Shortcut ito sa kanya. Okay? Then we say, store M4. This 12 here becomes, is transferred to M of 4. Okay? Then the next is load M of 1. What value will be loaded to the AC? Rafaela,
3 po, sir.
come again?
3 po, sir. 3.
Load M of 1. And then we say sub M of 2. What is M of 2? 1. So when we say sub M of 2, what will happen to AC? Justin Loresca. Justin Angeli, are you there? Tulog na siguro. Iliana Du. Iliana, are you there? Kent Agad. I'm calling you randomly now. Agad. Arthur Gabriel Nelias.
Yes, sir.
Yes. AC is now 3. We are saying sub M of 2. M of 2 is fixed at 1. What will be the value here?
2 na po, sir.
2, which means this will be the next multiplier.
Yes po.
And then we store it here to M1, so this becomes 2. Okay, thank you. Okay, load M4. Mike Niklos Ling, are you there?
Yes po, sir.
Tawag na ba kita?
Ay, wala pa, sir.
Very good, so it's your chance. Load M4, what will happen to the AC here?
12 na po ang value, sir.
That's the next partial product. Thank you.
Thank you, sir.
And then mul M of 1. What is M of 1 here? Kasi? Empisaw?
Ano, sir? 2.
2. So what
Ay,
will
wait lang. Ay, tama ba? Mali. Sorry.
2 ang M of 1.
Tama ba?
So what will be the result in the AC?
Ay, wait lang. 24.
24, that's correct. Because 12 times 2, 24, okay? Wait lang, ah. Okay. $24, no? Anyway, it's a mole M1. And we say store M of 4. What will happen? Where will 24 go? Gian Christian?
M4 becomes 24.
Oh, okay, good. No, dito, no? So, raising the program. This is no longer the worksheet of Ada Augusta King, no? Kasi wala na siya ngayon, no? Load M of 1. What will be this value? Sino pang hindi ko natawag? Jason, Dave Tungala. Jason, Dave.
2 po, sir.
Okay. Asan ba tayo? Dito, no? Load M of 2. So this M1, sorry, this is 2. Okay. Okay, so M of 2, remember, is no, load M of 1, that's 2. And then M of 2, remember, is always 1. So when we say sub M of 2, what happens to AC? Kevin, Rian, Kevin, Angkos?
Maging 1, sir.
Maging 1, okay? And then we store it here, so this is our last multiplier. So anyway, to make a long story short, we load M4, it becomes 24. Mul with M1, this is 24. And we store to M4, this is 24. And we halt. Doing a halt is jumping to itself. No, this is jump to the left. Jump 14, 0 to 19. Okay, take note that we have the instructions labeled R and L. No, L is the first, followed by the R, followed by the L, followed by the R. Okay. Any questions so far? You can download this worksheet, no, from our regular class. Any questions? Wala pa tayong branching and looping, no? Because we'll have to discuss the topic separately. Okay. So this is the example of Fahrenheit to Celsius. No? We convert the value 132 to Celsius. No? So the first multiplier, or rather, subtract 32. Subtrahend is in M2. The source is or the input is from M1, and then the divisor is in the multiplier is first multiplier is in M3, and the divisor is in M4, and the result is in M5. So we load M1. M1 becomes 132, and then we say A sub M2. What happens to AC? Si Iliana Do, hindi nakatasagot, di ba? Iliana, are you already there? John Fabul?
It will be 100 po, sir.
100. Okay, very good. Naka-ready na siya. No? Mul M3. Jomer Mandak? Jomer? If you don't have mic, you can, ano, no? Manuel Telmo ask a question. Alternating yun na always after every command. Sir, alternating talaga yung L and R. Okay? Because ito sana dapat nandito sa right. Do you follow?
Ay, so, sir, tanong po.
Luis,
Yes po, tanong po. So, ano po mauna yung L or R po?
una ang L kasi left man.
Ay, okay po.
Do you follow? That's the problem with with the IAS. One of the problems. I'll discuss that later. No? Pagkatapos nito. No? So AC receives AC times 5. Okay. John Kyle, Lampa. John Kyle, are you there?
Yes po, sir.
What happens to AC here?
500 na po.
500. Okay. And then we have the AC receives AC divided by 9. M4, by the way, we'll just make the formula. It's 55.56. And it's stored to the result, no? By store M5, and then we stop here, no? Okay. Before I discuss that problem, no, of L and R, let us load the meters to feet. This 4 meters. I'm sorry, balik. No, this is 4 here. It's 3.28 here, no? Okay. We'll store the result on M3. We load M1, so AC becomes 4. We move M2, it becomes 3.18. No? 4 times M of 2. And then store M3, we store the result here, and then we hold. Any questions so far? Okay. Now, why is the problem like this? Why do we have an L and R and L and R for instructions? What's the predicament of a John Van Neumann? Anyone? Kasi, in the first place, he needs to make data 40 bits. Diba? After the analytical engine. 40 bits so that it can accommodate large values and small values. Do you follow? It can be used for very accurate scientific computations. Do you follow? So 40 bits, nowadays it's 32 bits. Okay? Do you follow? 40 bits during that time is not compromisable. No? It's not negotiable. Computers have to be 40 bits. Now, this problem did not occur in the IAS, or rather in the analytical engine, because you do not have to store programs into memory. Do you follow? Wala ito sa analytical engine because instructions there are not transferred to memory. They're just in the input device. Now, when you transfer a program into memory, your instruction should be very small because there are only few instructions. No? In which case, instructions at most can be 20 bits. So you have to split a word into L and R. Otherwise, the R part will be left unused. Do you follow? If you just follow 1, 2, 3, 4, 5, 6, 7, 8, only the left part will be used. Jesse Manuel, did you get that? Because,
Yes, sir.
kasi kung walang R, only the left is used. What will happen to the R? It's wasted. And memory during that time is very expensive. It's worth a fortune. Even now, no, it's not that expensive anymore, no. But about 10 years ago, no, it's very expensive. No, it's like jewelry. Do you follow? So, to accommodate that wastage, he accommodated the right. So, pwede na tayong mag-jump to the left and jump to the right. Okay? Any questions so far? So you are not going to solve a new assignment, but I'm going to show it to you. No? Okay? Because you cannot do it without looping. Okay? Even the ano pala, no, the edvac is also jump left, jump right. And IBM 701, jump left, jump right. But during the time of deck, they reduced the to 32 to somewhere like 30. So naging uniform na yung instruction and data. We follow? Do you follow? Nowadays, uniform na yung addressing ng instruction and data. So you are going to compute the sum of the 4 numbers in the IAS. I've given you the factorial. Okay, so you can just edit that. No? Celsius to Fahrenheit. I've given you Fahrenheit to Celsius. No? An average of the first 3 numbers, this time with loop. Okay. Any questions on the IAS? Okay. You have any questions? So I will not introduce a new topic anymore, no? This will be too much. Okay. Ano ba tayo? 4-101? No. 4-100. 310 pala, no? Aguelo? Bataga? Deo Caresa? Nasin? Hala Khalil? Gabriel Armand Seras? Okay. So any questions? We'll discuss the previous assignment on CF next meeting. Okay. So if you have no questions, we will dismiss the class.
Sir, question. Sa deadline lang. Kailan po ang deadline para sa lahat ng assignments?
The next assignment o sa ito. Ito wala pa ito, no? Next week pa ito.
Ay, yung last assignment po.
Monday.
Monday? Okay po.
It's only a single program, okay? Madali lang yun, no? So Monday. Okay? Any other questions?
Question po, sir.
Yes, Elena.
Kailan po prelims, sir?
Come again?
Prelims po, sir.
Mag-schedule pa ba ng prelims? Wala nang schedule yan, di ba? But we will have our first formative test soon, no? Do you follow?
Thank you po, sir.
Pagkatapos natin ng history of computing, we will have our first formative assessment. Okay, any other questions?
Hi, sir. Is the formative assessment graded na po, sir?
Come again?
Is the formative assessment po, is that a graded quiz na po, sir? Hindi po.
Yes. Graded na ngayon, no? Do you follow? Graded na. Lahat ng formative and performance tests are graded. Okay?
Okay po, sir. Thank you.
Okay. Any other question? Any other question?
Excuse me, sir.
Yes, Jeffrey.
Mag-ask lang ako, sir, ba? Anong walang nakalagay dun sa right instructions po?
Yes. Dito ba tayo sa 4 factorial? Jesse?
Kahit
Yes.
saan po. I'd like to ask lang po, ba't walang nakalagay sa right instruction?
Dapat dito sana yan, di ba? Diyan yan.
Opo.
Di follow dyan yan dapat.
Oh,
It's also supposed to be here. Di follow?
yes, sir.
Eh, ito lang nilagay doon because it's difficult to trace if you are going to move vertically and horizontally. Di ba?
So, parang inalign niya na lang po lahat.
Alayin ko na lang din. No, actually, dito
yes,
siya.
sir.
Nandito rin yan. Di ba? Andyan rin yan. Do you follow?
Yes, sir.
Okay. But
Yes, sir.
actual
Thank you,
location
sir.
is there, okay? I-align ko lang para when we trace so vertically. Okay? Any questions? Others? Okay. So we'll dismiss the class now. Everyone, thanks for coming. I'll upload the recording.
Thank you, sir.
Thank
Thank you,
you.
sir.
Okay, goodbye.
Yes,
Thank you,
sir.
sir.
Thank you,
Goodbye, sir.
Sir, bye po.
Bye, sir. Thank you, sir.